I will be correcting my mistake I made, my explanation of uh, labeling and explaining leading versus lagging strand in DNA replication. So we're going to start out with our drawing of our DNA strand being unwound, and then we'll have our replication, the fork splitting. So again, we're going to have we have 5' right here, 5' end. It'll be a 3' end. This initial 3' end will be over here. But since it's splitting, this will be an end right here, and then this will be an end. So it'll have to match 3' right here, 5', original 5' ends over here, 3' end right here. Okay, so we'll start out with the leading strand. So of course, since this occurs and is read 3' to 5', so you start up here with this one. So AUCG to make our primer. DNA polymerase would continue it, starting with primer started, and then this would of course be replaced by nuclease, so the RNA is replaced with DNA base pairs, and then ligase would of course come and seal it. And so it would of course happen 3' to 5' direction. So it's going in the direction in which the fork is opening. The forks are opening. So that's the first telltale sign that it's leading strand, because leading strand will open, or replication for the leading strand occurs in the direction in which the opening is occurring, which is this direction, of course. So it would continue, and it would go at the same, and replication would occur at the same pace in which the DNA is being unwound. So it won't come to a stop at any point. It'll just continue at a constant rate and go as it's being opened. So this could be the leading strand, and through this understanding, 3' to 5' end, as same as up here, from the inside going the same direction as the fork's opening, you could figure out that this is also a leading strand. So moving on to the lagging strand, it's then going 3' to 5'. It's going in the opposite direction of the fork opening. So that's one way. The way to identify the lagging strand mainly is that its DNA replication is occurring opposite the direction of the DNA strand opening. So right here, since it's not open over here, the primer would start right here, RNA primer, and then it would continue, but of course come to a stop because the forks are opening right here, and on this side, the sequence is replication is occurring in this direction at its own start. And so once again, it would be replaced with the help of nuclease to correct this to DNA. Ligase comes to seal, but of course comes to a stop, and it has to wait until the DNA unwinds more, so that there's more of the strand for it to start on. So this would be known as an Okazaki fragment right here. And what will happen is another primer, if it opened up to over here, another primer would occur, and then more Okazaki fragments would be formed until it reaches the original primer location, which will connect to that, and then again it'll be lagging because it has to wait until more of the DNA unwinds so that it can continue the replication, because it's not going in the direction in which the fork is opening.